This illustration deals with a 120 volt single phase 2-wire system. Notice in the illustration the transformer rating is 10 kVA, but we're only taking 120 volts from the transformer. So we have a 120 volts single phase 2-wire system supplying the panel board. What this illustration illustrates is what would be the amp rating of the ungrounded conductor terminating in the breaker, as you see in the illustration. So calculating the amps of the transformer is in the boxed in information right below note 1. Notice the amps can be found by taking the kVA times 1,000 and dividing it by the voltage. Amps is equal to 10 kVA times 1,000, and we kind of use the 1,000 to get rid of the K and have in the formula just VA. So when we divide 10 times 1,000 times 120 volt, then the amps on the ungrounded conductor is 83 amps. So basically we could, in the 2020 NEC, go to our table 310.16, and based upon a 75-degree terminal, a number for conductor could be used to supply that breaker. And that breaker could be 90 amps or 80 amps, depending on if you round down or round up, whatever would meet your need. And then notice, based upon the number for conductor, we would go to our table 250.66 if we were connecting to a metal water pipe that's good to be used as a grounding electrode, and we could select the size of our grounding electrode conductor from table 250.66. The grounding electrode system, as just pointed out, we're going to say it's a water pipe. A legal water pipe that is considered an electrode with 10 feet or more of it in the earth per section 250.52A is an Apple 1 of the NEC. And then of course your main bonding jumper, if you, for example, as the designer installer, you were supplementing the screw that grounded the grounded terminal bar to the enclosure, then it would also be sized from based upon table 250.66 in the past. But the 2020 NEC, as you well know, would have a table 250.102C1 that would be used to size that main bonding jumper. But really, the table 250.102C1 is in CAR, basically as an overlay of table 250.66. But many times I get the question, why two tables? Well, the table 250.66 deals with sizing the grounding electrode conductor. This confused people. So they provided a new table, 250.102C1, that lists the supply side bonding jumper, the main bonding jumper, the equipment bonding jumper on the supply side, and so forth. In other words, the terms and items listed at the top of the table reflected to the user of the table exactly what the table provided the designer, installer, or maintainer to select the size of the conductors based upon grounding electrode conductor or supply side bonding jumper, main bonding jumper, and so forth. Those items that are listed in each table. And then, of course, the grounded conductor shown coming and terminating to that grounded terminal bar, it too would be sized from table 250.102C1 to carry the fault current if such a condition develops somewhere in the system. But you would also design that conductor based upon neutral current from 220.61 and select the larger, either the larger calculation of 220.61 as a neutral, or a path for the fault current to travel over per table 250.102C1. That's just a little extra information. Now, in closing out this illustration, let's review the note 1. When rounding a number down, we see 220.5B. And when we say rounding a number down, we're talking about if you had, say, 83.5 amps, that could round up to 84 amps. If you had 83.4, it would just stay, you'd round down to 83 amps. However, Article 240 would allow the user to take the ampacity of the conductor. In fact, it's 240.4B as in boy. And if the conductor rating, number 4, is 85 amps, you could move up to 90 amps to get the full benefit of the 85 amps. Or you could just round it down to 80 amp overcurrent device and you completely protect that conductor's ampacity. So it's a choice. Which choice do you make that would give you the biggest benefit out of using that number 4 conductor? So this figure 4-1 mainly just deals with taking a 120 volt single phase 2-wire service and determining, based upon the rating of the transformer, how many amps would be usable at the service equipment.